Hello, I'm Chandaban Kapoor. Uh, I'm a trainer at Go Master Technologies, and this is the YouTube channel of Go Master Technologies. I've been posting solutions of lead coding challenge on daily basis, and this is one of them. So today's lead coding challenge is out. Um, it's September 28th, and the problem for today is subarray product less than k. So the definition of the problem is simple. We have an array of positive integers, and in that array, some subarrays, when you multiply all the elements of the subarray, the product is less than k. So we need to count all the subarrays or the number of subarrays which satisfy that constraint, right? So it's a counting problem. All we need is that one counting number, right? So let's understand the problem with this simple example. They have already done that. So here we have an example which has four elements, 10, 5, 2, 6. And if you figure out, there are 8 subarrays which whose product is less than 100. All the elements which of single elements, which all of them are lesser than k anyway. And there are 3 of them uh, with just 2 elements in the subarray. They are also less than 100, and there is only one with 3 elements which is less than 100. But look at this, there is another one with 3 element, 10, 5, 2, which is equal to 100, so it is not counted, right? Obviously the subarray having all the elements is also not counted. All right, so we need to count that. Let's see how can we solve this problem. So I'm thinking of a variable sized sliding window problem here. So the idea of sliding window is there is a starting point called I, and there is an ending point called j of a subrange, right, of a bigger array. And so and this slides to the right side starting from extreme left, and every time j also increments and I also increments, not every in same iteration, but they only increment so that it always progresses to the forward direction. And I'm thinking of maybe a linear time solution to this. But otherwise, a brute force solution could be quadratic, because there are quadratic number of subranges. And if you figure out, if you can find the product of each range in some constant time, then we can actually solve it. But the thing is, big O of n squared solution is not acceptable. Look at the value of n. So n is already 5 into 10 power 4. N squared is will be more like 25 into 10 power 8, which is kind of prohibitive. Right, so let's try our sliding window idea. Let me just explain with this example itself. So we have 10, 5, 2, 6. The idea goes this way. I'm going to have a sliding window having only one element, which is 10. The product is 10, so it is acceptable. I'm going to count as 1. This is the first range I'm going to count. So when I increment j goes to this point. So now we have a product of 50, and that is also acceptable. Now there are two ranges which has this new element, like 10 is already there. So but 10 comma 5 and then 5 both are acceptable. So those are the two ranges I'm going to have. Now when I increment j here, the product has gone up to 100, which is not acceptable, right? So what I'm going to do is I'm going to shrink I, or an increment I, so that I shrink the window. So I is going to come up to this point. So now this is acceptable. So but the ranges ending at 2 were not counted. Now if we see, there are two ranges ending at 2. One is 5 comma 2 and another one is 2. So those are the two I'm going to add here. Now when I when I increment j, so it's going to include 6, and this is also acceptable. Look at, the product is only 60, which is less than 100. And there are three ranges including 6, which is 5 to 6, and 2, 6, and then just 6. So these are the three ranges I'm going to add. And now j is already pointing to the last one. There are no more new ranges you're going to get, right? Even though you can shrink I and then figure out, but that is not useful, because if you shrink, or if you increment I and then shrink from the left side, you will get a new range called 2 comma 6, but that is already added here. So this is all we have, 8 ranges. So I'm going to use this idea to basically come up with an algorithm. I'll also maybe quickly go through another example which probably explains some border cases. So I just expanded this example itself. I'm going to have few more elements, so 10, sorry, 100, 200. Maybe I'm going to use 10, 5, 2, 6 from the older example, and maybe another 100 here, and then some few ones, and then another 100 here, right? So what happens is we need to find the first range. In earlier example, the first element was actually acceptable, but here 100 is not acceptable, right? Because suppose if k is equal to 100, that is already beyond the range. So I'm going to find the first element that is less than k, because that should be the beginning of the first range. So 100 is not useful, 200 is not useful, so 10 is useful. So my first range is going to start and end at this 10. So that's how I have one one range which is acceptable. Now when I increment j, my product has went up to 50, right? So 50 is still acceptable. There are two more ranges I'm going to add up. Now when I increment j, it's going to include 2. My product goes up to 100, which is not acceptable. That's why I'm going to increment I. So I is going to come up to this place. Now this is acceptable. There are 2, the size of the window is 2, so I'm going to add 2. Now again, I'm going to increment j here. So the window size is 3 and the product is 10 into 6 is 60, which is acceptable. So 3 more of them. Now when I increment j, the product goes up to 6,000. Obviously it is greater. I'm going to start incrementing I. So when I keep incrementing I, you can see that I keep dividing by 5, 2, and then 6, but still the product is 100. So that's why I even divide by 100 so that I is going to go beyond this j, right? So that's how my product has reduced to just 1. All right. But yeah, when you see this, the size of this range is actually 0. That's why there are no new numbers we're going to add. Maybe we're going to add 0. That's what it means. Now when I increment j, j is going to be same as I, and the product is still 1. So I'm going to add 1. When j is incremented to here, the product is still 1. So I'm going to add 2 of them. And when j is incremented to the next one, there are 3 more ranges. I'm going to add 3 more. When j is incremented to this, again the same idea. So I keeps incrementing and I goes beyond this one. So the 0 is added here, right? So when j increments to next one, it's going to skip it, right? Because it adds 0 and then it should skip it. So the answer is 8 plus 6, 14. So we should get 14 for this example, right? I hope the idea is clear. The approach is clear. Let's quickly code this. So I'm going to start with this idea of finding the first number, which is less than k. So while I is less than nums dot size, sorry, nums dot size, and if nums of I is greater than or equal to k, I keep skipping. Sorry, greater than or equal to k, I keep skipping. Right, so this is where I come down to, and so now I should be pointing to an element which is less than k. But what if none of the elements are less than k? Then I is going to be equal to num size. That's a case I want to make sure here. So what happens in this case? There are no range subarrays which satisfy. So my answer is going to be 0. Right? Otherwise, I is going to be inside the array and it is pointing to the first element which is less than k. Right? So that's where j is also going to point to. So I have j here. And the product of the current range is going to be nums of I or nums of j, right? Which is the same thing. This is the product. Now I need to count the number of sub ranges, which is what they're expecting. I'm just going to call it as result. So result is, maybe I should call it as 1, but I'll call it as 0. Okay, my idea here is I'm going to use some kind of while loop here. Here, every time I want to, because when I get into this, my idea is there is a valid range. I need to count all the sub ranges which are ending at j, right? So that's what we figured out, and that's essentially what I'm going to do here. So which is j minus of new ranges which are valid I'm going to add. So that's why that is my invariant. When I come inside this while loop at line number 12, I have a range which is valid, right? So this is what we have. Now I'm going to expand. So in every iteration, I'm going to expand by only 1, right? And if this goes beyond the array, so that is the time to stop it, right? So if it is equal to this, I'm going to break, which is essentially going to stop this iteration, right? Now, otherwise, if not, I included new elements, so my product is going to increment. So I'm going to multiply nums j to that product so that my new product is what we have. Right? So we have done this one. We have included new one. So I want to go for the next iteration, but before that, I want to make sure if product is greater than or equal to k, I need to shrink from the left side, right? I need to increment I. So I may not even increment if product is already less than k. So that's why I is going to increment for 0 or more number of times. But how long? It can reduce the window size maybe even up to 0. That's also possible when nums of j itself is greater than or equal to k. Because if nums of j is greater than or equal to k, the range cannot end at j, right? But according to this, the range should end at j and it should be valid. So that's why if I say I is one more than j and j is pointing to a number greater than k, that is as good as saying we don't have any ranges to add up. And this number j minus I plus 1 is going to be anyway 0 there, right? If I is one more than j. So that's why I'm going to do something like this. As long as I is less than or equal to j and product is greater than or equal to k, I'm going to keep, removing one element from my window. So the idea of removing an element is, first of all, you divide that element, uh, divide the product by that element, and then increment I, right? So this is essentially what it means. Now, once I'm done with this, the new loop is going to start and we have a valid range. If you don't have any valid range, obviously I is going to be one more than j. So this is still valid in a way because I'm going to add 0, right? So this is the termination condition which will get us out of the while loop. So I think there is no other condition needed for this one, right? And finally, when I come out of this, the result is going to have the answer, right? Let's see whether it works for the test case. I just came up with. Sure, it works. Look at this. This is the test case I just explained, and the answer is 14. So 8 from this range and 6 from this range. All right, it should work. Let me quickly submit and see whether it is acceptable. It is acceptable. I hope this ran pretty quickly. Yeah, this is somewhere at 95 percentile, so it should be quick. But yeah, let's see what is the time complexity of this whole method. If you see here, I keeps incrementing up to some extent, and whatever number of times I is incremented, j is going to start from there. And in every loop here, j is incremented by once. So this while loop and this while loop put together are going to run exactly n number of times. But there is one more while loop inside here. But if you see there, j is never touched there, not even decremented or incremented, only I increments. You don't have to worry about I because when j touches the end, we are going to end anyway. So this cannot execute, overall it cannot execute for more than the size of the array itself, right? Because I is also incrementing. At some point when I crosses j, we are going to anyway stop, right? So I is always kind of limited by j. That's why the whole thing works in linear time. And this is the lower bound for this problem. And the space complexity is anyway constant. All right, so that's all we had. So make sure you code at least one problem a day to keep your coding life healthy. Right, happy coding.